Hello guys, welcome back to the channel. Today we are doing longest nice subarray Leetcode 2401, which also happens to be the problem of the day for today. So let's have a look at what the problem statement says. It says you are given an array nums, something like this as input, and what you have to do is this. We call a subarray of nums subarray. Let me highlight this part because this is something which I really got stuck at. I did not focus on this part and I thought that they were talking about a subsequence, and this actually led me to sort of waste around 40 to 45 minutes of mine. But then this is very important. This is very important for you to read the question carefully. We call a subarray of nums nice if the bitwise and they are talking about bitwise and some, I don't know how to draw it, but bitwise and of every pair of elements that are in different position in the subarray is equal to 0. Return the length of the longest nice subarray. This is what our task is. Length of the longest nice subarray. A subarray is a contiguous part of an array, and if there is, for example, no nice subarray, then a single element is always considered nice, so you can return one, right? Let's have a look at the first test case. The answer to this is 3848, because if you take this particular subarray and you calculate the bitwise and of each and every element, for example 3 and 8, then you calculate 8 and 48, and then you calculate 3 and 48, all of these combinations are going to give you a 0. Why is that so? Let's have a look. So 1, 2, 4, 8, 16, 32. So let me first represent 48, then I will represent 8 and then 3. So 48 is 1 1 0 0 0 0, and then this is 1 0 0, right? And then 3 is this. So you can very clearly see, देखो, one very important point for you to note over here is that the bitwise and of any two numbers, it's going to be greater than 0 when those two numbers have an overlapping set of overlapping, you can say, region of set bits. Now what do I mean by this? You can very clearly see that there is no overlap of set bits over here. So for example, if I AND 48 and 8, I'm going to get a 0. Why? Because 1 and 0, 1 and 0, 1 and 0. The rest of them are 0, obviously. If I AND 8 and 3, 1 and 0, 1 and 0, 1 and 0, and the rest of them are 0. Right. So this is as simple as it is. One very important piece of information for two numbers to give you an AND of 0 is that they shouldn't have an overlapping region of set bits. Right. If we take an example at this particular test case, then one thing is there is one thing which you will observe, that all of these numbers are odd. So by default, no matter what these numbers are, their this position, this 1, is always going to be set, isn't it? Because they're all odd, none of them are even. So 100% this is going to be set, and that's why the longest nice subarray that we have, that is 1. Why? Because each and every number has this bit as overlapping. Now, what do I actually mean by it? Let me just very quickly tell you. For example, if I had 3, 1, 5, 11, 13, let me just go into a little bit depth of what I'm trying to say. 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, and then 1, 1, 0, 1. Now, take any two numbers and try to calculate their bitwise end. What you are going to observe is that 100% that and is going to be greater than 0. Why? Because all of these bits are set. You getting my point? All of these bits are set. So let's have a look at what our thought process is going to be when we are trying to solve this particular problem. Okay, at this point you have a very good idea that this particular question is related to what topic? It's related to bits manipulation. At some level we have to manipulate the bits, isn't it? And then one very important point, they are talking about a sub array. whenever we are talking about subarray, whenever we are talking about a contiguous piece of an array, which technique comes to our mind? The very first technique which comes to our mind is what? Sliding window. So let's see if we can somehow combine bit manipulation and sliding window and come up with an optimal approach to solve this. But then before we talk about the optimal approach, let's first consider for just a second, for just a minute, let's just consider what the brute force approach is going to be. Right, the brute force approach is going to be as simple as that. I'm going to calculate each and every subarray. So I'm 1 1 3 1 3 8 1 3 8 48 1 3 8 48 10, so on and so forth. I'm going to these are just 5 of the possible subarrays that I have. I'm going to consider each and every subarray, which is going to take me O of n square time complexity, and then I'm going to check for each of that subarray. I'm going to check if it's nice or not. But then you can very clearly see that nums dot length can be 10 to the power 5. So if I square it, that's going to become 10 to the power 10, which is greater than 10 to the power 8. And 10 to the power 8 is basically our acceptable time complexity range, isn't it? So if I do the brute force approach, it's 100% not going to be accepted. We have established that, right? So how can I do anything which is better than O of n square? That is something which I'm trying to think about. That is something which we are trying to think about. So let's see. Okay, let's see. Let's try to sort of see if if taking a sliding window approach can help us at this point. So I'll take a I pointer, which is sort of the start of my window. I will take a j pointer, which is the end of my window. Right now my both of those pointers are at 0. These are my initial conditions. And then what I have to do is, see, this is very important. What I have to do is I have to make sure that the sub array which I am talking about, is nice. And then what qualifies a particular sub array to be nice? Just like I said over here, this is very important. Put your maximum focus over here. What qualifies a sub array to be nice? That particular sub array, whatever numbers it has inside of it, for example 3, 8 and 48, those numbers should not have an overlapping region of set bits. Are you getting my point? Those numbers should not have an overlapping region of set bits. So the thing is, the critical part, the actual hard part over here which we have to solve is this thing. How can I make sure that inside a particular window, whatever numbers that I have, they don't have an overlapping region of set bits? How can I see that? So let's have a look. Okay. Now, initially, what I'm saying is that the window initial conditions are that I'm not talking about any number right now. My window hasn't even started right now. Okay, my window is empty. So the current bit set is 0, 0, 0, 0, 0, and the current maximum length is also 0 because I haven't considered anything at all. Now, what's the first thing which I'm going to do? I'm going to consider the first number. So since this particular bit is set, I'm going to set this particular bit as well. Now, why am I saying that? Because at this point, 1 is inside my window. Okay, so obviously the maximum length is also going to be 1, isn't it? Because 1 is inside my window. Then I'm going to try to expand my window. Okay, I'm going to try to obviously expand my window. Why? Because I need to maximize the size of the nice subarray, right? So I'm trying to find out what is the longest nice subarray. I'm going to expand it. But then when I expand it, I actually did a mistake over here. This is 0, 0, 0, 1, 1. Then when I expand it, I see that these two bits are actually colliding, isn't it? Dekho, very, very important for you to understand. If I take 1 and 3, I am not going to get a 0. What I am going to get is 1. You know why? Because these two bits are overlapping. You get my point? When I try to, and do this by yourself, try to take the bitwise AND of 1 and 3, you're not going to get a 0. And since you're not going to get a 0, then that means that 1 and 3, if both of these numbers are in the same subarray, then that particular subarray can be called as nice. That subarray isn't nice. Why? Because the AND of two numbers which are at different positions, is not equal to 0. As simple as that. So now, since my condition is not being met, I'm going to try to shrink the window, isn't it? I'm going to try to shrink the window. The important thing is, when I shrink the window, let's see, I just do this. I shrink the window. What happens to my current bit set? This is the important part. How is my current bit set going to change? For now, let's just say I remove the 1 from it, because that is what I have to do, right? When I'm shrinking, what do I have to do when I'm shrinking? I have to remove those bits from my current bit set which were set in 1, isn't it? So before I shrink my window, I have to remove this 1 from my window. Very carefully listen to this. Since I'm shrinking my window, I have to remove this particular 1 from my window, right? This particular one. And then since I'm introducing 3 to my window, 3 has both of these 2 bits as on. So I'm going to make both of these 2 on. So what I did was, I first removed the set bits of 1. First, I removed the set bits of 1, this one, and then I switched on the set bits of 3, which was something new to my window, right? And obviously the maximum length again is going to be 1. Alright, I hope everything is clear till this point. Now I have 2 bits which are on, this one and this one. Then I again try to expand my window, right? What I will observe over here is that there is no clash. This bit is on, this bit is on, and this bit is on. So I'll just go over here and I'll make this bit on as well, and I'll say that the maximum length which I have encountered at this till this point is 2. Then I again increment my j and I try to again expand my window. My window starts from here. Previously it was ending at this point, but then I'm including this particular number as well. And again what you will observe is that there is still no clash. This bit is on and this bit is on. So no clash, right? Both of these are off right now. So I'll go and I'll on both of these bits and I'll say that the maximum length is 3. The maximum length which I have got till this point is 3. Then again I try to expand my window in a greedy way. I try to see if I can get a length which is greater than 3. But then when I come at this point, I see that both of these bits are colliding, are clashing, right? This is on as well and then this is on as well. So in this scenario, listen very carefully. What do I need to do? Listen very carefully. At this point, you know for a fact that I'm going to shrink my window, right? I'm going to obviously shrink my window because my condition is getting false. The current window which I'm talking about is not nice. So I shrink my window, I increment my I. But then just very carefully listen to this. When you remove 3 from the window, you need to off these 2 bits. You see, you need to off these 2 bits. So you're going to turn them off. What did I say? I said you are going to turn them off. Now just keep in mind over here, we are just dry running the solution. And this is actually the beauty of this question. We are going to observe it when we code it up, but then for now, remove the complexity. But what we have to do is we have to, since we are removing 3 from our window, I need to remove these 2 bits. So I increment my I, my current window becomes equal to this. What I observe is that there is still a clash. This bit is on and this bit is also on. So I need to off this particular bit. I'll do that. Right. I offed it. I again shrink my window. These 2 bits are on, these 2 bits are still on. Again, there is a clash. So what I need to do is I need to turn them off as well. And then I will again shrink my window. Right. And then when I come at this point, I see that now there is no clash, isn't it? Now my I and my j are at the same position. And now there is no clash. So what I'm going to do is I'm going to turn both, since this is the new number which was introduced to my window, I'm going to turn both of these bits on over here. Okay, on over here, and then I increment my j goes out of bound. Okay, the size of this particular window was 1, but then again it was smaller than 3. isn't it? It was smaller than 3, so I don't update it. And at the end of the day, what answer do I have? I have the answer as 3, right? Till this point, everything is good and clear. But then the only questions now which we need to ask from ourselves is the implementation part, isn't it? How exactly, and this is the most important part, how exactly are we going to modify the current bit set? How exactly am I going to introduce a number to my current bit set? And how exactly am I going to remove a number from my current bit set? Isn't it? For this, you need to know two principles. Alright, let's talk about what those principles are. You see, one very simple thing. Let's say we have 0, 0, 0, 0, 1, and then let's say we have 0, 0, 0, 1, 1. Okay, my current bit set was 0, 0, 0, 0, 0. Sorry, 1. This was my current bit set when I only had 1 inside of my window, right? But then when I tried to introduce 3, you very well know that this particular bit and this particular bit had a clash. So what did I say? I said I need to do two operations. I first of all need to remove 1 from the window, and I need to introduce 3 inside my window. So in order to remove 1 from the window, I need to off this bit. One very simple way of turning this bit off is by taking the XOR of this number with 1. You see, if I take the XOR over here, this is going to become 0, isn't it? And then once I have taken the XOR and once I have turned this bit off, then what I can do is, in order to introduce this particular number to my window, I can take the OR of this particular number. You see, if I take the OR, then what will I have? I will have this, which is actually my current bit set when I have only 3 inside my window. When this is my window, this is the current bit set. And then let's say I want to expand my window and I want to include 8 as well. I'm not talking about shrinking right now. Since there is not a clash, there is not a, if you take 3 and 8, there is no overlapping region of set bits. So there is I do not need to shrink the window. I just need to introduce 8 to the window. So what I'll do is I'll just directly take the AND. Okay, I'll just directly take the AND of these two numbers. So this is going to become something like this. And then again, I'm going to try to expand my window. I have 48 over here. So what I'll do is I'll just again take the OR simply. So at the end, my current bit set becomes what? 11101, and this is my current bit set when I have these 3 numbers inside my window. Okay, but then when 10 comes, 10 is actually what? 10 is 001010. 10 is 001010, and you can very clearly see that these two bits are clashing, isn't it? These two bits are clashing. So at this point, I need to shrink my window, isn't it? I need to shrink my window. What I do is, देखो, listen to this very carefully. I am trying to include 10 in my window, but I cannot. Why? Because if I include 10 inside my window, my subarray no longer becomes nice. So what I'm going to do is I'm going to try to shrink my window. The very first thing which I do is I remove 3. How do I remove 3? This is very important. Listen to this very carefully. It's a very important learning point for you. How do I remove 3? This is my current bit set, isn't it? I take the XOR with 3. You see, I take the XOR with 3. When I take the XOR with 3, these two bits are going to turn themselves off. And then when these two bits actually turn themselves off, that means that I have successfully removed 3, isn't it? But then if still you can very clearly see that 001010, I still have a clash. I have a clash between this bit and this bit, isn't it? I still have a clash. So what I'm trying to do is I will have to remove the 8. I will have to remove the 8. When I do so, how am I going to do it? I'm going to say take the XOR with 8. So when you do so, this bit also gets off, isn't it? And since this bit also gets off, that means that I have successfully removed 8 from my window. Okay, I have successfully removed 8 from my window as well. And now the window that I'm considering is what? 48 and 10. But you know that 48 and 10, tell me, 48 and 10, if I add these two numbers, do they categorize as a nice subarray or not? If you very carefully observe, then this is what 48 is, right? 1, 2, 4, 8, 16, and then what is this is 16 and this is 32, and then 10 is actually this. So there is not an overlapping of set bits. I actually made a mistake over here. I shouldn't have removed 48 from my window at this point. Why? Because 48 and 10 are not clashing. So if you have 48 and 10 inside a subarray, then this particular subarray can be called as nice. Okay, so now I do not need to shrink my window any further. I need to introduce 10 to my current bit set. Why am I introducing 10 to my current bit set? Because I'm trying to expand my window. So how do we introduce any number to our window? We just take the OR. As simple as that, isn't it? We just take the OR. So this becomes my current bit set, and after I have included 10 in my window, I increment my j goes out of bound. This length was 2. I had two numbers inside the subarray, but then we very clearly saw that 3, 8 and 48 had a length of 3. So ultimately we returned 3, isn't it? So this is as simple as it gets. Now let's try to code this particular solution up. Okay, so you can very clearly see that I have track bits as 0. This is my track bits. Okay, I have I as 0. I have the j as 0 initially, and I have the max length as 0 initially as well. What is the first thing that I do? I introduce, I'm going to introduce one inside my window, right? How am I going to do that? I'm going to say track bits or nums of I, isn't it? Or not nums of I, actually nums of j, because from j I actually expand my window. Now we only need to know how exactly do we do OR. The way to do that is this, something like this. Track bits is equals to track bits or nums j. Okay. After doing this, what I have successfully done is I have added nums of j to my current window. Okay, to my current window. And then obviously I'm going to do is I'm going to update the max length. I'm going to take the max of what max length currently is and what my new window size is. So again, this is something which is fixed. How do you calculate the length of window? The length of window right now is 1. You do j minus I plus 1. Simple as that. You don't even need to think about it. Whenever you are asked to find the length of a window, you do j minus I plus 1, and that is very easily mathematically understood as well. Okay, then after this particular code is executed, what's going to happen? I'm going to increment my j. When I increment my j, what I observe is that these two bits clash. Now, how am I going to write the code for this? Now, again, what I need to do is, sorry, I forgot to update my track bits. I need to update my track bits over here, right? That is exactly what I did. Now, what I'm seeing is that there is a clash. So I need to shrink my window. I need to shrink my window. How am I going to shrink my window? I'm going to say something like this. While track bits, and nums of I, you see, this is the person who's causing a problem. This is the person who's causing a problem, right? Because of this person, the subarray which I'm getting is not nice. And why is it not nice? Because the track bits are getting greater than 0. So I'm going to say while track bits and nums of I is not equals to 0, I need to shrink my window, isn't it? I need to shrink my window till the point where track bits and nums of I becomes equal to 0. What I'm going to do is I'm going to take the XOR just like we did over here, isn't it? Just like we took the XOR over here. That is exactly what I need to do at this point as well. Now, thing is, how do we take the XOR? something like this. Track bits is equals to track bits XOR nums of I. So after the compiler executes this line, nums of I is successfully removed from my track bits. You see, if I, this is my track bits right now. What I'm saying is take the XOR of track bits with 1, with this number itself. So isn't it going to turn this bit off? It's 100% going to turn this bit off, isn't it? And then what I do is I say that I plus plus, yani increment the start of my window. So now the current window becomes this, and then when you compare this particular track bits with this, when you take the AND of them, you are going to get a 0, and that is when you stop shrinking the window, isn't it? So let's see if I run this test case, if it passes the test cases. It did not. Why? Because I wrote incorrect spelling over here. Compile error. While track bits lower precedence, so I need to wrap this around brackets. Okay, because and has a lower precedence than this. Track bits B capital. Okay, let's see if it passes all the test cases. It does not. Why is that so? What answer I am getting out of this is 1, whereas I should get a 3. Oh, I'm actually making a very small mistake over here. I need to check the AND of track bits and nums of J, isn't it? Because although this bit was on, but then the clash was observed when this number got AND with this particular number. So it should have been a J over here. Let's see if it passes all the test cases. It does. Let's see if it passes all the hidden test cases as well. And then what we are going to do, it does, right? We can very clearly see that the time complexity of this particular code is going to be O of n. Why? Because we visit each and every number only once. For example, if this was my array, then what I did was I only visited each and every number just once throughout my journey, right? And you can very clearly see that the space complexity is going to be O of 1 because I'm not taking any extra space over here. I'm just taking variables, right? I hope you liked the video and I hope you understood the basic principles and fundamentals of bit manipulation from here. And if you liked it, do let me know in the comments. I'll see you next time. Till then, take care.